Hello guys, welcome back to a new video. Now in this video we'll be learning how can we calculate molar mass, molar volume, distance between two atoms, and then we'll be solving section review and practice 2A questions. Now look, we have sample problem 2A. It's solved in the book, but I'll solve it again so you can understand better. Now look, you have the question like this: estimate the distance between two atoms of copper, knowing that its molar mass is 0.064. Now look, you remember in the previous video that we learned to find distance, we were using an equation, which was L is equal to cubic root of volume. Now here it says find or estimate the distance between two copper atoms. Now look, you have L, which is unknown, okay? You have two atoms of copper, knowing its molar mass is 0. So you have molar mass. Careful, don't write M alone, because if you write M alone, it means it is the mass of a single atom. It's different. Its density is equal to what? So rho of copper is equal to 8,000 kilogram per meter cube. Okay, cubic meter. Assume that sometimes, it depends on your teacher, but you should be given Avogadro's number in the question, okay? Otherwise, you have to memorize it. You have 23, 6.02 times 10 to the power 23 inverse mole. Mole inverse. Now look, these are the givens. Remember, what equation were we using to find the distance between two atoms? Okay, in the previous video we said length or distance is equal to cubic root of volume. Now let's take a look at the givens we have. So these are the givens, careful. These are the givens. Let's take a look at this one. Do we have volume of a single atom? No, we don't. Okay. Do I have other things to find molar volume and then find volume of a single atom? Let's see. Now to find, guys, always do this and you'll never make a mistake in calculation. Do I have, or let's say, what equation were we using to find volume of a single atom? This V means volume of a single atom. Careful, it's different than molar volume. Now look, we had V, which is volume of a single atom, is equal to molar volume divided by Avogadro's number. Now look at these values that you have here. Do you have molar volume? No. Do you have Avogadro's number? No, you don't. Yeah, sorry, you have Avogadro's number. So you only have Avogadro's number. You need to find what? You need to find molar mass and put it there and find this one. Okay, and then put it right here. Okay, now look. Let's first find molar mass. Molar volume, sorry. So you have density, which is equal to molar mass divided by molar volume. Okay, you have molar mass divided by molar volume. Now look, do I have density? Do I have density? Yes, I have. Do I have molar mass? Yes, I have molar mass too. Can I find this one? Yes, I can. So the equation will be what? Let's rearrange the equation. You have density divided by 1, molar mass divided by molar volume, cross multiplication. So you have molar volume is equal to molar mass divided by density. Okay, now put the givens. So you have molar volume is equal to molar mass. We have 0.064 kilogram. Then you have density, which is equal to 8,000 kilogram per meter cubed. Kilogram goes with kilogram. You have what? You have, divide this number and you'll get 8 times 10 to the power of minus 6. The final unit is what? Meter cubed. This is what? This is molar volume. Now let's take this number and put it right here. Okay? So you get what? You'll have volume of a single atom is equal to what? Is equal to molar volume divided by Avogadro's number. You have this number, 8 times 10 to the power of minus 6 meter cubed, divided by what? Avogadro's number, 0.60.2 times 10 to the power of 23 mole inverse. Okay, now this is volume of a single atom. Okay, careful, this is V alone. Divide this number and you'll get what? You'll get 1.33 times 10 to the power of minus 29 meter cubed. This is what? This is the volume of a single atom. Now we said what? You said put this number here in the cubic root of length. So you have what? You have length, which is equal to cubic root of volume. So you have cubic root of what? Of 1.33 times 10 to the power of minus 29 meter cubed. Meter cubed will be cancelled with this one. So take the square root, take with the cubic root of all this number, and you have what? You have 2.36 something, but let's say 37 times 10 to the power of minus 10 meter. This is what? This is the distance between two atoms of copper. Okay. Now this example is solved in the book, but it's better to practice it and learn how can you find the distance between two copper atoms. Now look, you have practice 2a. Practice 2a says what? Question 1, the equilibrium distance. So remember our note, equilibrium distance between two neighboring atoms of a given element is 1.2, so this is our note, times 10 to the power of minus 10 meter. Would the inner atomic force be an attractive or a repulsive one when the distance between the atom is, so look, this is the distance between, you have R, this is R, and this is R. Careful, R note never changes. It's only the distance between the two atoms that changes. R note is the equilibrium distance. It's like a boundary. These two atoms cannot cross this boundary, okay? It's like a limit of every electron, okay? Now you have 1 times 10 to the power of minus 10. Remember, we said that if the distance between two atoms decreases, the force among these two atoms will be what? Will be repulsive. Here, the distance has decreased from 1.2 to 1 meter, okay? And the power is the same, okay? So distance has decreased. So the force is what? The force is repulsive. You have 1.4 times 10 to the power of minus 10. The distance has what? Distance has increased. So the force is what? The force is attractive. The force here will be attractive. Now, what are the three types of bonds of atoms? Are these bonds due to electric forces or due to gravitational forces? Gravitational attraction. Remember, we had three bonds. We had ionic, covalent, and metallic bonding. metallic bonding. Are these, the second part of the question, are these due to electric forces or gravitational attraction? These bonds are due to electric forces. You had electrons donating, receiving, you had electrons sharing, you had an electron, let's put it this way, you had ionic bond, which was about donating or receiving electrons. You had covalent bond, which is about sharing electrons. And you had metallic bond, in which you had an electron, which was moving freely in a sea of electrons. So you have electrons, so it's electric forces, okay? Positive and negative charges. You have section review 2.1. Does matter change from one phase to another due to exchange of mass, charge, or energy? Remember we said a phase can be changed through two things. Through giving the phase thermal or mechanical energy, okay? So it's what? It's in the exchange of what? Of energy. So due to exchange of energy. Or you can put it this way, due to the exchange of potential energy to kinetic energy. Question 2. These two questions regarding, it's 3, I'll come back to this one. Repulsion between two atoms at very close distances due to interaction between the electronic clouds. Is this repulsion due to the fact that electrons are small, or the charge, or the mass? The repulsion between two atoms, we studied this one, is due to the electronic charges, or due to the electronic clouds. So it is due to their charges. Question 3 and question 2 from practice 2a. From question 1, okay? This question 1, question 3 here, okay? You can be given the dependent of forces, the graph that we studied in the previous videos. You had equilibrium distance, you had distance between two atoms. You can be given or you can be asked in these two ways. Either you are given the equilibrium distance and it tells you that the distance has decreased or increased, or you can be given this one, okay, like this. Most probably like this. So comment on the distance, the force distance curve between atoms in 3 regions. Okay, now look. It says R is equal to 0, okay? Now you have the distance between two atoms, okay? Sorry, it doesn't say 0, it says R is equal to R naught, okay? So you had two atoms, okay? Atom A and atom B. R is equal to what? Is equal to R naught. Okay, here R is equal to R naught. You remember what was this called when R was equal to R naught? It was called equilibrium distance, or equilibrium state, equilibrium state. There is no push and there is no pull from neither of the two electrons, okay? You have B, which says the distance between the two atoms is 0, okay? So you have atom B, atom A, okay? Let's say the distance is 0 now, okay? You have the equilibrium distance here, R naught. The distance between the electrons now is 0, okay? It's 0. So it will be here, because the distance between the electrons has decreased. It is so small, it will be what? It will be repulsive. Repulsive force. The force among these two atoms is what is repulsive. You have C, it says infinity. It means any number, okay? So you have two atoms, B and A. Let's put A here, okay? Any number it says. Let's say this is the equilibrium distance. Okay, this is R naught. But you see R is so large, it's so big, okay? The distance between the two atoms is too great, okay? So the force will be what? Will be attractive. attractive force. Okay, it can be asked like this when it comes to the dependent of forces or the force distance curve. We have question 4. The molar mass of sodium is 22.98 grams. Okay, so this is what? This is molar mass. What is molar volume? Knowing its density is 9.71. So density is equal to what? Density is equal to molar mass divided by molar volume. Okay. Do you have molar mass? Yes, I have. Do you have density? Yes. It says find molar volume. You don't have molar volume. Rearrange the equation. So you have molar volume is equal to molar mass divided by density. So this one will be what? Will be 20.98 divided by 9.71. I think you will get 2.43 centimeters cubed. Okay, this is gram. This is kilogram per centimeter cubed. Grams cancel, so you have centimeter cubed. This is it for today. See you in the next video.